Okay, everybody, here's where we put all of the pieces together for arithmetic series. We're going to talk about a general formula for finding the sum of an arithmetic series without actually having to add up all the numbers in between, and then we'll apply it a few times in an example to make sure we know how to use it, and then we'll be done for today. So, the setup is, suppose we have an arithmetic series. Suppose we have a sequence an is an arithmetic sequence, and we're going to turn it into a series by just adding the terms together, is an arithmetic sequence. So it has this formula to give the nth term of the sequence an is equal to a1 plus d times n minus 1. To find the sum, if we start with a1 plus a2 plus a3 plus dot dot dot, and we do it k many times to ak, well, here's how we do it. The general strategy is we want to find that sum. We want to find the answer to that, which is, I'll call it capital A. And the way that we do it is we take that series and we flip it around and we write it underneath. So then here we have a k and a k minus 1 and a k minus 2 and dot dot dot, and this is a 1. And we won't go through the process of showing it now, but the idea is that if you add up each of these pairs vertically, a1 plus ak, that gets you a1 plus ak. A2 plus ak minus 1, the thing to think about is that if the common difference is d, then a2 is going to be d bigger than a1, but ak minus 1 is going to be d less than ak. So increasing this one and decreasing this one by the same amount, it adds up to the same sum. So even though this is a2 plus ak minus 1, it's equal to a1 plus ak. And in fact, what we get is that all of these are equal to a1 plus ak. And the last one you can see is equal to ak plus a1, which is a1 plus ak. And that's equal to 2a. Now, how many of these were there? We started at 1 and we went up to k, so there were k many. What was it that we were adding up? It's k many times. It's this thing, a1 plus ak, and there are k many of them, so we do k times a1 plus ak. And that's equal to twice the sum that we want, because we've added this sum and then it's to itself. So in order to get just a formula for the sum, I'm just going to divide both sides of this formula by 2. And how does this look? Well, it gives us a sum. A is equal to k times a1 plus ak over 2. That's typically how we write it because it makes it a little easier to remember. The parentheses a1 plus ak over 2, we just think of this as looks like the average of the first term and the last term. Add them up and divide by 2, and then take k many copies of that, and that will give you a, which is your sum. I've used the letter capital A here, but maybe I'll clarify that as follows. That formula that we're giving, it's really the formula for the sum of I equal 1 to k of ai. This is the formula when you want to figure out the sum. This is just sigma notation for the same sum that we have here. This is the formula. And what is nice is that this you can just, as Gauss did in his classroom in the last example, you can just plug in, if you know how many terms, that's k, and you know the first and the last term, then you can plug into this formula and get the answer directly of what it would be if you added up all of those terms. It's a way of jumping straight to it without having to actually add them all. Let's see how this works in practice. So this is example 23.15. Find the sum a1 dot 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 a60 for the arithmetic sequence an equal 2 plus 13 times n minus 1. So let's see. We want the sum a1 plus dot 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 plus a 60. And the sequence looks like this. It's a n is equal to 2 plus 13 times n minus 1. Now, what we need are the following things. We need to know k, which is how many terms. K equals how many terms? Well, we started at 1 and we went to 60, so k is equal to 60. We need to know the first term, a1, and we need to know the last term, ak. If k is 60, then this is a 60. How are we going to find these? Well, we have this formula. You can use this formula to find any term that you like. So to find a1, we're just going to substitute 1 in here. A1 is equal to 2 plus 13 times 1 minus 1, which is just equal to 2. Another way to think of it is that in this formula, this is A1 and this is D, so the A1 is just 2. All right, that's good confirmation. So our A1 is 2. Our A60, well, we're going to substitute in again, but putting in 60 for n, so A60 is 2 plus 13 times 60 minus 1, which is 2 plus 13 times 59. That counts in my book as a tricky one, so we go to our calculator. We figure out 13 times 59, it's 767. So this is 2 plus 767, which is 769. So that's our last term, A60. This is our first term, 2, and this is our K60. And from those, we can figure out this sum. It's the sum I equal 1 to 60 of AI. What is it equal to? Well, we take k many of them, 60, and the thing that we take k many of is the average of the first and last term. So it's 2 plus 769 divided by 2. This is, let's see, it's 60 times. On the top, we get 771, and on the bottom, we get 2. I can cancel the 2 and the 60, and it leaves behind a 30. So this thing is 30 times 771. And plugging that into a calculator, you get that this is 23,130. That is our final answer. That's the sum of the first 60 terms of this sequence. Now you can imagine we could use the formula here to generate each term. A1 we found, we could find A2, A3, A4, A5, A6, all the way up to A60 and add them up by hand, and that would take forever. This has managed to do it in much fewer steps, 23,130. That's the result of adding all of those numbers up. Okay. Go ahead, pause the video now, take a look at parts B and C on your own, see what you can make of them, and then come back and we'll work on them together. All right. Oops. So, part B, determine the value of the sum. They use j instead of I, that's fine. J equal 1 to 1001 of the sequence, the arithmetic sequence, that's given by 5 minus 6j. Now, let's see, what are the things we need to know? We need to know k, that's how many terms. And since this sum starts at 1 and goes up to 1001, k is equal to 1001. We need to know a1, that's the first term. The first term is what you get when you plug 1 into here. This is like your formula for the terms. So this is 5 minus 6 times 1, which is 5 minus 6, which is negative 1. And then finally, we need to know the last term, a sub k, or a sub 1001. And we'll get that by plugging 1001 into that same expression here. So we have 5 minus 6 times 1001, which is 5 minus 6006, which is negative 6001. So we now have our final term. We have our initial term, and we have our k. And so now we can get our sum, the sum of our series, just by using our formula. It's equal to k, that's 1,001, times the average of the first and last terms, so minus 1 minus 6,001 divided by 2. Simplify that thing, and you're going to end up with the following. It's negative 3, let me see, I'm going to count zeros to make sure I got these in the right place. 0, 1. So this is 3,004,001. Negative 3,004,001. That's what these guys, 1,001 terms, add up to. That's our answer for part B. Let's take a look at part C. I'll grab a copy of this one so we can work on it and look at it. Here we go. Find the sum of the first 35 terms of this sequence. I see I've made an error. Let's, whoops. When I copied, it was hard to tell the difference between two important symbols, which are commas versus periods. Let me see. I'm going to grab it again. This is the kind of thing that could really mess us up later if you mistake a comma for a period or vice versa. All right. Find the sum of the first 35 terms of this sequence. And the sequence is 4, 3.5, 3, 2.5, 2, 1.5, etc. And I guess there's a question, which is this actually an arithmetic sequence? It has these decimals running around, and it doesn't seem completely straightforward or obvious. Let's just think it through a little bit. So, to get from 4 down to 3.5, we are subtracting 0.5. To get from 3.5 down to 3, we are subtracting 0.5. To get from 3 down to 2.5, we are subtracting 0.5. And it looks like each time we are subtracting 0.5. And so this seems to be an arithmetic sequence where the common difference is d equal negative 0.5. That's our common difference. And it seems to be arithmetic. That is, there is the same difference each time. The things that we're going to need to know in order to find the sum, if we add all of these guys up, are we're going to need to know how many terms, and in this case, the first 35 terms, so k is 35. We're going to need to know A1, the first term. Well, the first term in the sequence is given to us here. It is 4. And then we're going to need to know A sub 35. And the trouble is, we were only given 1, 2, 3, 4, 5, 6 terms of this sequence, and we need the 35th term. Now, I could, of course, just keep writing down terms of the sequence, each time subtracting 0.5. But instead, because I would have to do that like 30 more times, that would be really annoying. Instead, in order to figure out this, I'm going to find a formula for the nth term of the sequence. So first, find a formula for a sub n. Now, this is an arithmetic sequence. If we just think about the sequence, we're not adding things up yet. For the sequence, it looks like this. It's a1 plus d times n minus 1. So an is equal to a1 we have already, that's 4. The common difference we found was negative 0.5, and then times n minus 1. And now what we would like to do is find the 35th term of the sequence, and so I'm just going to take this expression and plug 35 in. Plug in 35. Let's make that n equal 35, so it's really clear. N equal 35 to find A35. Well, what is it equal to? 4 plus negative 0.5 times 35 minus 1, which is 4 minus 0.5 times 34. And employing a calculator, we see that that 35th term adds up to negative 13. So that's our A35 is negative 13. We can go ahead and fill that in. We'll just stick it back in there. I'll make it a different color to make it clear that we didn't start with that. Negative 13, that's what we got there. Okay. So this side work was all to find A35, because once we know K and we know A1 and A35, then we can plug into our formula and get them. So let's go ahead and figure out what this sum is, the first 35 terms of this sequence. This sum is going to be equal to K, which is 35, that's how many of them we're adding up. And then what are we adding? It's the average of the first and last terms. So first term is 4, plus the last term, so minus 13 over 2. This is 35 times negative 9 over 2, which is equal to, if we do a little multiplication there, we get negative 315 over 2, or you can get it as a decimal. If we divide, it's negative 157.5. So either one of these is a fine answer. All right, that's it. That's using the basic formulas. What are the formulas that you need to know? You need to know the formula for adding the sum of an arithmetic sequence, and you also need to know the formula for the nth term of an arithmetic sequence, this one. And those are the two formulas we've been using mainly here. That's it for today. Try the web work. It will give you some experience in working with sequences in series in general, and specifically arithmetic sequences in series. And do please contact your instructor and me if you have any questions.